Hello everyone, welcome to EPG Pathshala. I am Dr. Soma Sarkar. Today's module is on energy resources, distribution, livelihood and scarcity concerns. This is the paper from Resource Geography. Through this lecture, you should be able to understand what is energy resource and simultaneously classify the different sources of energy. Even you can document hydrocarbon energy sources like coal, petroleum and natural gases and electricity. And you can also understand and study the importance of non-conventional sources of energy. Now the question arises, or let us start with what is energy. Energy is understandable as a power or capacity to work. It is the primary input in the production of goods and services. More regular and ample is the availability of energy, more even will be the path to economic prosperity. The role of energy has significantly increased with the increase in industrialization and urbanization in the present day society. Depending upon is the source, and energy resources can be divided into two broad classes. One is traditional or non-commercial like firewood, charcoal, cow dung, industrial waste and also power and animal power. Another one is the commercial energy that comprises of coal, oil, natural gas, hydroelectricity, nuclear power as well as wind and solar energy. Again, the energy can be classified, energy resources can be classified on the basis of conventional like coal, petroleum, natural gas and electricity, and non-conventional like solar, wind, tidal, geothermal energy, biogas and so on. Now, let us one by one explain these energy sources that I have mentioned. Now, the first one, let us discuss on coal. The coal is an inflammable organic substance composed mainly of hydrocarbon found in the form of sedimentary rocks and capable of being used as a fuel to supply heat or light both. Coal is continued to be mainstream of power generation in India. It constitutes about 70% of the total commercial energy consumed in the country. The power sector and the industries accounts for about 94% of the total consumption. Due to its high utility as a source of energy, experts show that the world coal reserve are 6 times the known reserve of oil. Coal originates from the organic matter, wood. Large tract of forest lands were buried under sediments in the geological past, maybe that is in Carboniferous age. So, the wood was burnt and decomposed due to heat from below and pressure from above. During the pressure of change from the wood to coal, the amount of oxygen and nitrogen decreases and the proportion of carbon increases. Thus, the capacity of coal to give energy depends upon the percentage of carbon contained in it. The percentage of carbon in coal mainly depends upon the duration and the intensity of heat and pressure on wood. Depending upon its grade from higher to the lowest, there are 4 varieties of coal. One is anthracite coal, bituminous coal, lignite, and the lowest in the quality is peat. Anthracite coal are the best quality and contains about 80% to 95% of carbon. Very little volatile matter or negligible small amount of moisture. They are very hard, compact, jet black coal having semi-metallic luster. It ignites slowly and burns with a nice short blue flame. It has the highest heating value and is the most prized among all the variants of the coal. In India, it is found only in and around Kashmir, and that too in very small amount. Bituminous coal is most widely used coal. It derives, as it names, from a liquid called bitumen released after heating. This one varies greatly in composition in amount of carbon content, that is from 40% to 80%, and the moisture and the volatile content also varies from 15 to 40%. It is dense, compact and is usually of black color. Its calorific value is very high due to high proportion of carbon and low moisture content. It is used not only for steam raising and heating purposes, but also for production of coke and gas. In India, it is mainly found in Jharkhand, Odisha, West Bengal, Chhattisgarh and Madhya Pradesh region. Lignite, as the name suggests, it is also called brown coal, lower grade coal that contains about 40 to 55% of carbon. Represents the intermediate stage in the alteration of woody matter into coal. Its color varies from dark to black brown. It is friable and pyritous. Its moisture content is high, above 75%, so that it gives out much smoke but little heat. Its typically qualities make it liable to disintegrate on exposure and even to spontaneous combustion. It is found in Rajasthan, Tamil Nadu, Assam and parts of Jammu and Kashmir. Pit is actually the first stage of transformation of wood into coal and contains less than 40% of carbon. Significant volatile matter and moisture is also present in this coal quality. Now, left to itself, it burns like wood, gives less heat, emits more smoke and leaves a lot of ash after burning. Now, about the global distribution on coal production, it was the first fuel to be used on a large scale due since industrial revolution, of course, the massive use of coal in industrial purpose. Most of the resources were formed during the Carboniferous period. Now, China and US together contributes about 60% of the coal production in the world. China has been the main coal producing country in the world since 1986. USA coal mining shows a declining after the Second World War due to subsidized oil and gas prices, development of nuclear energy and environmental restrictions, but it picked up after the oil crisis of 1970s. In Europe, coal is mined in France, Belgium coalfield, in Ruhr, Saar, Silesia, then in parts of Germany and in Poland, UK, Spain and central French plateau. Therefore, the whole distribution is mainly concentrated in the said areas, and as I have said, in Australia, coal is mined in New South Wales, Queensland, West Australia. In Africa is very little coal except of small amount that is found in South Africa. In recent time, the production of coal in India, Poland and Australia has been going up, while that in UK and Germany it has been going down. Now, let us move to petroleum. The word petroleum has been derived from two Latin words, that is petra, which means rock, and oleum, that means oil. Petroleum is an inflammable liquid composed of hydrocarbons, which constitute 90 to 95% of the petroleum. Remaining is organic compounds containing oxygen, nitrogen, sulfur and traces of oregano, that is the metallic compounds. Compact and convenient liquid fuel has revolutionized transportation, can be easily transported from the producing areas to the consuming areas. It emits very little smoke and leaves no ash and can be used till last drop. It provides the most important lubricating agent and is used as a raw material for various petrochemical products. It is found in sedimentary basin, that is the shallow depressions and in the sea. Most of the oil reserves in India are associated with anticlines and fault traps in the sedimentary rock formations of say tertiary time period. Oil and natural gas originated from the animal or vegetable matter contained in shallow marine sediments are the cause behind the formation of the oil. Conditions were favorable especially in the lower and middle tertiary period. Oil on a commercial scale is usually found where the sedimentary rock strata are inclined and folded in the highest possible situation. Being lighter than water, it collects in the anticline or fault traps. Gas is still lighter and occurs above oil. Oil seepage is not always a sure indication of an oil reservoir. In India, geological and geophysical studies have been conducted in 14 basins while exploring drilling in 9 basins. Mumbai, the Khambat Gulf and the Assam are the most productive areas. It is found in dome-like structure of sedimentary rocks. About the distribution of oil in global scenario, say for in USSR, it was first struck in the Caucasus region, which has been the traditional oil producing region. West Asia accounts for more than 50% of the world oil reserve. Oil was struck here in 1909 for the first time. In Saudi Arabia, Iraq, UAE, Bahrain, Oman are also the important oil producing countries. Myanmar is a region also where oil can be found, and in India it is beside the above Assam, Gujarat, Bombay High are the important oil producing regions. Africa has limited reserve which are spread over Egypt, Libya, Algeria and Nigeria. North Sea in Europe, the oil resources here are sharing among UK, Norway, Germany, Denmark and Netherlands. Honshu and Hokkaido in Japan and Yangshan region and Shanxi province in China are important oil producing region in East Asia. Of the total oil reserve of the world, the former USSR region has 22%, USA 15.5% and Saudi Arabia has 9% contribution. Now let us move on to natural gas, which consists largely of methane and other hydrocarbons occurring naturally underground. A flammable gas used as fuel when the layers of decomposition plants and animals takes place. USA and the former Soviet region are the major producer in this, and other natural gas producers are Iran, Qatar, Canada, China, Norway, Netherlands, Saudi Arabia and Algeria. In India, survey conducted in 1997 in the Andamans has revealed 1700 billion cubic feet of gas reserve, which can meet the country's requirement for the next 30 years. The gas discovered by Reliance Industry in deep waters of Krishna Godavari offshore basin are the largest discovery of natural gas in the world in year 2002. In June 2005, ONGC made a significant hydrocarbon find in shallow waters of Krishna Godavari. Here the reserves are estimated at 4 to 5 trillion cubic meters. About 3/4 of the total gas comes from Mumbai High. Over 11% of the total gas are produced by Gujarat. Now let us move on to electricity. It is a form of energy, clean and produced, no residue can be transported over long distances. Then hydropower is the cleaner but more capital intensive sources than thermal power. Norway, Sweden, Switzerland, Canada and New Zealand have developed their hydel power potential, while China, Japan, USA and the former Soviet region are leading producers and the consumer of hydel power. South America, 75% of the total electricity used are from hydroelectricity. Similarly, India has major multipurpose projects from where it generates electricity like Bhakra, Nangal, Hirakund, Bokaro, Panchet and many more. Electricity scenario in India can be represented as the per capita consumption in India was only 373 kilowatt in 2002-3 and which has increased tremendously in the present scenario with the development of industrializations and of course urbanization. Following types of electricity are recognized, that is hydroelectricity, thermal and nuclear electricity. Hydroelectricity, the future prosperity of India depends on how greater extent of our ability to produce and use hydroelectricity in a renewable, cheap, clean and environmentally source of energy. India is blessed with huge water resources and there are vast possibility of producing hydroelectricity. The NHPC was set up in 1975 and following the influences of development of hydroelectric power in India, there should be perennial flow of large volume of water, there should be fall from a sufficient height, a readily available market is an essential requirement for generating HEP, hydroelectric power generation, and generation of hydroelectricity also requires huge amount of capital investment. It also requires technological advancement because production, distribution and utilizations are closely related to the technological level. Some factors which favors the development of hydroelectricity in peninsular India are its topographical significance that feature on the upper reaches of the major rivers are seldom favorable for development of irrigation, would not clash with our priority for use of water. Western part of the peninsula are far away from the coal deposits of the northeastern plateaus. They have to depend upon the hydroelectricity power to meet their energy requirement. Now, let us move on to thermal electricity. It is generated by using fossil fuels like coal, diesel and natural gas. The thermal power generation recorded more than 181 times increase between 1950 to 2003 and 4. The National Thermal Power Corporation was established in 1975. At present, NTPC has 13 coal-based super thermal power projects and 7 gas liquid fuel-based combined cycle project. It has an installed capacity of 19,435 megawatt. Thermal electricity accounts for more than half of the installed capacity in 14 states. In the states of Assam, Bihar, Jharkhand, Chhattisgarh, Gujarat, Mizoram and West Bengal. It accounts for more than 90% of the installed capacity. The next is the nuclear electricity. So, it is obtained from uranium and thorium. Uranium is available in the copper belt of Jharkhand and the rocks of Aravallis in Rajasthan. The Menazite sands on the Kerala coast also contains uranium. It is also obtained from mica in Gaya and Udaipur and Jaipur regions beside parts of Andhra Pradesh. India has vast repository of thorium accounting for about 50% of the world's total is enough to generate about huge amount of electricity energy for next 300 years. Now, let us talk about the non-conventional sources. New sources of energy which have not yet been fully exploited. It is of course solar energy, wind energy, biomass energy, hydropower, hydrogen on one side, and new techniques such as fuel cells, electric vehicles, ocean energy, geothermal energy, and so on. Besides being renewable, they are also non-polluting and environmental friendly in nature. India has non-conventional energy potential of about 1,95,000 megawatt. So, of this total potential, 31% is provided by solar energy, 30% by tidal or geothermal energy, 26% by biomass, and 13% by wind energy. As of the end of 2016, the worldwide total cumulative installed electricity generation capacity from wind power amount to about 4 lakh megawatt, that has increased of about 12.5% compared to the previous years. So, now let us talk about these energy sources one by one. The first is the wind energy, which is cheap, pollution free, and as I have said earlier, environmental friendly in that sense. As of 2014, top 5 producers of wind energy in world are China, US, Germany, Spain, and India, with a capacity of more than 1 lakh megawatts. China has by far the world's biggest wind power sector, accounting for 31% of the global total. The United States boasts wind energy capacity of about 65,000 megawatts. The US wind industry has had an average annual growth of about 25.6% over the last 10 decades, which is just amazing. And the Germany, in that sense, it has 39,000 megawatts of wind energy with 10% of the global total. So, what is the stand of India in this sense? India is also fast catching up with Spain despite being a relative newcomer to the wind energy sector. India had 22,000 megawatt, more than 22,000 megawatt of wind power capacity, having added more 2,000 megawatt during the present year. Now, let us talk about the solar energy. It is non-exhaustible, reliable, and immense and pollution free in nature. It may be utilized for water heaters, distillation plants, power generating devices, space heating, air conditioning and refrigerations, and many more things. Presently utilized through 2 different routes, that is solar thermal route and solar photovoltaic route. Solar photovoltaic technology converts sunlight into electricity used by a variety of low power applications such as telecommunication, railway signaling, and street lighting. Worldwide growth of photovoltaics is extremely dynamic and varies strongly by country. By the end of 2016, the cumulative photovoltaic capacity increased by more than 75 gigawatts and reached at least 303 gigawatts, significant to the supply of 1.8% of world's total electricity consumption. The top installer of 2016 were China, United States, and India. There are more than 24 countries around the globe with a cumulative capacity of more than 1 gigabyte. Austria, Chile, and South Africa all crossed 1 gigabyte mark in 2016. The available solar photovoltaic capacity in Honduras is now significant, that is sufficient to supply 12.5% of national electricity power, while Italy, Germany, and Greece can produce between 7 and 8% of their respective domestic electricity consumption. Regarding the biomass energy, it is again a clean and cheaper source of energy, and it improves sanitation and hygiene as well, removes the produce rich organic manure for use in agriculture. Bioenergy may be obtained through biodegradable material like animal dung, human night soil, kitchen waste, water hyacinths, then agricultural residue and city waste and so on. This can be of crucial importance in the poor predominantly agricultural countries like India and China. Geothermal energy is our next concern, that is this energy produced by using heat generated in the earth's interior, which is available on the earth's surface in form of hot water springs and geysers. This form of energy is being produced in USA, Iceland, Italy, Japan, New Zealand and Ladakh region. Based on current geological knowledge and technology, the Geothermal Energy Association estimates that only 6.5% of the total global potential has been trapped so far, while the IPCC reported that geothermal energy potential to be a range of 35 gigawatt to 2 gigawatt. So, as of 2015, worldwide geothermal power capacity amounts to 12.8 gigawatt, of which 28% are installed in US. International markets grew at an average annual rate of 5% over the last 3 years, and the global geothermal power capacity is expected to reach about 14 to 17% of gigawatt by 2020. Countries generating more than 15% of their electricity from geothermal sources include Kenya, Philippines, Iceland, Costa Rica and many others. There are vast possibility of developing and exploiting geothermal energy in India too. About 340 hot springs localities have been identified so far. Many of them have temperature nearing boiling point. Assessment of the geothermal energy potentials in the selected sites of Jammu and Kashmir, Himachal Pradesh, Arunachal Pradesh, Uttarakhand and Chhattisgarh has been already undertaken. Now, let us move on to tidal energy, a clean but very expensive method of producing electricity of course. Some western and developed countries are producing electricity in this manner. India processes 8,000 to 9,000 megawatt of tidal energy potential, and it is mainly the Gulf of Kambak is the best suited area for about 7,000 megawatt potential of tidal energy. This is followed by Gulf of Kutch and Sundarban region. So, in conclusion, it can be said that energy is the basic necessity of power to mobilize and sustain all life system, social and economic progress and level of living. Due to technological efficiency, non-conventional energies are used in our daily life. About more than 75% of the energy comes from 3 fossil fuels, that is coal, petroleum and natural gas, and very little from nuclear power. It is a good sign that world is rapidly moving towards non-conventional sources of energy that include solar, hydel, biomass and geothermal energy. India is also emphasizing on these energy sources, which is very useful for sustainable and clean environment. Thank you for joining me in EPG Pathshala. Thank you.